All right, so for the sake of my first hour, let's go back over number 3. Okay, we're on page 72 on activity 5-2. All right, going back over number 3. Consider a machine that exchanges quarters for dollar bills. Inserting $1 bill returns 4 quarters, and you may insert up to $5 bills at one time. Insert also means input, right? So you may input up to $5 bills, and your output would be 4 quarters for every dollar bill that you put in. Think about this before you start diving in and working on these, okay? Do I have to put in a dollar bill? No. I mean, how many change machines have you ever walked past, right? Do you have to put a dollar in? No, you don't. Okay. All right. It's one of those things that before, Chuck E. Cheese went to that whole little card method now that they do, right? You used to get tokens, and some of y'all are rolling your eyes. Y'all understand what I'm saying, right? You can go to Chuck E. Cheese and not play a single game. I don't know why you would, but it's possible, right? And so your inputs, right, is starts with 0. And what's the maximum? What's the most input that you can do? Yeah, up to $5 bills. Okay, up to $5 bills. All right, so your inputs, right, your domain would be 0, 1, 2, 3, 4, and 5, right? What your range? Your range is that you get 4 quarters for every dollar bill, right? And so a great way before, if you don't know what your domain and range is of something, a great way just to kind of figure it out, so that way you have it, is just make a t-chart, right? Remember your x values, all of your x values is your domain. All of your y values is, of course, your range. And we said 0, 1, 2, 3, 4, and 5, right? You can even make a function table if you want to out of this. A function table will get rid, it doesn't let me, I have to, let's see if I can just use the white and kind of clear that out. Nope, it doesn't let me do that, but it will kind of buffer it a little bit. A function table is where you just put the problem in the middle and your y is over here. And your function is that every time, right, I get 4 quarters. Well, that means that would be 4x, right? For however many I put in, I get 4 quarters for it. So if x is 0, 4 times 0 is 0, right? And we understand that. I put a dollar in. I mean, I don't put a dollar in, I don't get any quarters. If I put a dollar in, $1, how many quarters do I get? 4. If I put in 2, I get 8. We notice the pattern now. This is a constant rate of change. $3 gives me 12, then 16, and then 20, right? Is 7 a possible input for the relation of this change machine? Justify your response. Is 7 an input? Yes or no?
No.
Okay, why do you say no?
You can only input $5 at once.
Yep.
Less, right?
You can only put in $5. You can't put in 7. So 7, the answer is no. You may not input more than $5 bills at one time. What about 3.5? Can 3.5 be in the domain?
Well, if we're talking about dollars.
What's 0.5? If we're talking about dollars, what's 0.5?
Yeah, you could.
0.5 is, the 0.5 is a half dollar, right? It's 2 quarters. All right, it's not a dollar bill. Am I going to put in 2 quarters into a machine to get quarters out? No, that's dumb. Okay, and so can 3.5 be an input? No, because it can only be whole number of dollars. You only have dollar bills. You can't have a half dollar, right? If you rip that dollar bill in half, all right, not only do you not have half a dollar, you broke a federal law. Okay, So yeah, you can't destroy money. It's illegal. All right, let's look at C. What values are not in the domain? Well, the values in the domain are 0, 1, 2, 3, 4, and 5. So what values are not in the domain?
Anything above 5.
Any number that's not 0, 1, 2, 3, 4, and 5.
So anything above 5.
No, it's easier to say what's in it than to say what's not. Okay? Anything that is not 0, 1, 2, 3, 4, or 5. Any number that is not 0, 1, 2, 3, 4, and 5. Because that covers all of your rational numbers in between, all of your irrational numbers in between, and it also covers all their negatives. Okay? So it covers everything by simply saying any number that is not 0, 1, 2, 3, 4, and 5. Now, there will be an instance where you're going to say any number greater than or stuff like that, right? There is we will be doing that, but just not right at this moment. So any value other than 0, 1, 2, 3, 4, and 5 are not in the domain because you must insert a whole dollar bill, whole number of dollar bills, and you may not insert more than 5 bills at one time. D, is 8 a possible output for this relation? Output, what's my output? What is my output? Outputs are what?
The Y and
The Y, and what are the Y's? The quarters. Can I get 8 quarters?
yeah.
How? $2 bills, right? So if I insert $2 bills, I get 8 quarters. If I insert $2 bills, I get 8 quarters. Insert $2 bills, you get 8 quarters. Could 3 be included in the range of this relation? Why?
You can't insert 3/4
Well, no, we're not inserting quarters. What are we inserting?
money.
Dollars, right?
But you
Think-
can't insert $1 bills.
Yeah, think about that in real life. If I put $1 in the machine and I get 3 quarters, what am I doing? Am I happy? Am I like, hey, this is exactly how it's supposed to be?
You're getting less than you put in.
Yeah, you're going to see a manager or a worker saying, hey, this machine just took me for a quarter, right? Something's wrong. So can 3 be an input? No, because there is no whole number of dollars that is equivalent to 3 quarters. And then lastly, it's that same question about the domain, but this time's the range. What values are not in the range justify your reasoning? Any value other than 0, 4, 8, 12, 16, or 20 are not in the range because those are the only number of quarters you could possibly receive from the machine at one time. Let's take a look at number 4 now. Let's dive into number 4, okay? Especially because we should have just been checking our answers there. Let's dive into number 4. Number 4 says each of the functions that you have a finite number of ordered pairs. There are functions that have an infinite number of ordered pairs. Describe any difficulties that may exist trying to represent a function with an infinite number of ordered pairs using the 4 representations of functions that have been described thus far. So if the answer has an infinite number of solutions, how could that be hard for us trying to do these math problems? If there was an infinite number of ordered pairs. Like for instance, let's say that you have an infinite amount of money that can be put in, dollar bills that can be put into this machine, right? List all of the ordered pairs that's possible.
The range would go on forever.
Yeah, right? It would make it impossible for us to ever write this function, okay? If it's infinite, right, that means that it goes on. It means it has an unlimited number of elements. It means it would make it impossible for us to ever complete writing this function, okay? We'd be at 100 billion trillion, right? And we still wouldn't even be there, even close to writing out the total number for this. And sometimes a machine diagram is used to represent functions. The function machine below, the inputs are labeled X and the outputs are labeled Y. The function is represented by the expression 2x plus 5. So for 5a, it says, what is the output if the input is x equals 7? Okay. Well, how would we work this? Well,
Do 2 times 7 plus 5.
yeah, we would just do like we did before. We would make what you learned in 8th grade, right? It's called a function table, where you have your x and you have your y and you have your function in between. And so if x is 7, then that's 2 times 7 plus 5, and that equals your y. That's 14 plus 5, which is 19. So what is the output?
19.
If x equals 7, it's 19. Okay? Go ahead and do if x equals -2. Go ahead and do if x equals 1/2. Okay? Go ahead and do those. I'm going to pause it and give you a chance to do it. Pause the video and go ahead and try x is -2, x is -1. 1/2. I'm just going to use my space up here. You need to be working. Everybody's working right now. Just use my space. X, 2x plus 5, and y. And then this is 1/2.
Can I turn the 1/2 to a decimal?
I wouldn't.
Okay.
Whenever you look and whenever you remember that fractions is just division, it makes it a lot easier to solve. And I mean, plus, what's 1/2? What 2 times 1/2? What's 1/2 of 2? If you have $2 bills, how do I split that in half? Yeah. So 2 times -2 is -4 plus 5, which that would be 1. And then 2 times 1/2 is 1 plus 5, that would be 6, right? So my outputs are 19, 1, and 6. 19, 1, and 6. B says, is there any limit to the number of input values that can be used with this expression? Is there any limit to the number of input values that can be used with this expression?
No.
There's no limit, right? There's an infinitely many possible values that I can use as inputs. I can say x equals anything, right? I can say that x equals anything. And so there is an infinitely many possible values to use as inputs. Okay, number six. Number six is another problem as well, where they give you an A, B, C, and D. If you would, go ahead and let's work number six. Okay, if you would, let's go ahead and work number six. And I need you to actually be working number six, not you waiting for me to do stuff. And there is no reason for you to have a computer out right now. Zero. Calculators are on the wall, because I don't trust that you're using it for a calculator. And at this point in time, with the math that we're doing, you should be able to do this math in your head. Of course. All right, so you have a function here. You have make your function table. X squared plus 2x plus 3 equals y. Right, it equals y. You have your function table. What is negative 5 times negative 5?
25.
Positive 25. Okay. If you don't know what that is, that's something you need to commit to memory. What is 2 times negative 5? Negative 10 plus 3. 25 minus 10. 15 plus 3 is 18. Okay, so the ordered pair is negative 5, 18. If this is 3/5, right? 3/5. So 3/5 squared plus 2 times 3/5 plus 3. And again, this shouldn't scare us at all. Just because it's a fraction, okay, we work it in parts. So this is saying that there is 3 times 3/5s, right? So either you say, well, what's 3/5 times 3/5? Or you move the square, and the square, I'm going to square the 2, and I'm going to square the 5, okay? So what is 3 squared? 9. What is 5 squared? 25. All right? Anytime you are multiplying a fraction, a whole number times a fraction, you multiply the whole number times the numerator. Okay? You multiply the whole number times the numerator. We're not adding, we're multiplying, right? And so what this is just saying 2/1 times 3/5. 2 times 3 is 6. 1 times 5 is 5. So you just take the whole number and multiply it by the numerator, and that gives me plus 6/5, and then plus 3. So now I have an addition problem. Now I have an addition problem where all of them have a different denominator. And what is the least common denominator? Of 25, 5, and 1. It would be 25, right? Can 5 is 5? Can I multiply 5 times a number and give me 25? Yeah, right? So 5 times 5 is 25. So that's 9/25, right? Plus 5 times 6/5. And then what number must I multiply 1 by to give me 25? 25. So that'd be plus 25 times 3/1, which is just 3. Okay? That's not right. I'm sorry about that. Hold on. That's not right. That is, because that would give you, that would be, hold on. Sorry, I'm mixing things together, doing things off the top of my head. You got to multiply it by the denominator first. Sorry, the rule, I mixed up the rule with the other. You multiply it by the denominator, right? So what number will make, so you have this, you multiply to get the 6 over 5 to be 25, right? So that would be 5. And so you multiply it by the denominator, add it to the numerator, right? Add the numerator, and there you get whatever it is, right? So if you're going from 5 to be 25, that would be a 5, right? So 5 times 5 is 25, plus 6 is 31. And then you would do the same for this 3 for 25. That would be, you still multiply it. Again, you multiply it by the denominator there. So that would be 75 over 25. And then you just add your numerators across, right? 9 plus 31, right? 9 plus 31 plus 75 is 115 over 25. 115 divided by 25 is, the calculator says it's 4.6. The calculator says it's 4.6, but you need to leave it in fractional form, right? So if I would take out a 4, what's 4 times 25? 100, right? So if I subtract 115 by 100, I get 15 over 25. I can take out a 5 and get 3 over 5, and that's your answer. Okay? This is one of those where, again, if you're going to have something like this, you're going to have the calculator. You can just put this type of problem in the calculator and get your answer a whole lot easier. All right? But it's important for us to also know the math, even if you're like me and you haven't used it in a while. All right, so the next one would be negative 10. Negative 10, so that would be negative 10 squared plus 2 times negative 10 plus 3. Negative 10 times negative 10 is 100. 2 times negative 10 is negative 20 plus 3. So that's 80 plus 3, which is 83. All right. Number 7. Number 7 kind of gives us the same thing. It's a function table wanting us to do some practices. Number 7 and then also number 8 is the same thing. It wants us to do some practices. And so that is what I'm going to leave you with, is number 7 and number 8, wanting you to work those out. We have about 10 minutes left in class, so that's enough time for you to do those. And then for about the last 2 minutes, we will check them and go over your answers, okay? So go ahead and try number 7 and number 8. And then your homework tonight will be numbers 9 and 10. All right, and for those that are watching on the video, so you can check 7. Here you go. You can check your answers for 7. Check your answers for 7. And then you can check your answers for 8. And the homework tonight is 9 and 10. 9 and 10, that's the homework for tonight. So pause the video, do the homework, try it out yourself, come back, check your answers, There is the answers there. And then there's the domain and range for 9 and 10. All 9 and 10 want you to do is the domain and range. Remember, the domain is all the values of x, and the range is all the values of y. Don't write the values that repeat. You only got to write those once. Here in the graph, right, you just take your x values there, there, and there. Then your y values there. X-axis, the y value would be 0. There, and then there. Remember, down below the x-axis, that's negative. All right. And then B, like I said, there's B there. There's your domain. There's your range.